When training audio models for transcription or for text-to-speech, it goes a long way if you have clean and accurate transcripts that go along with audio. Some of the popular datasets that you might think are clean, such as Vox Populi, which is a Parliament dataset, in fact have errors, and this can result in bad training performance even when you expect there to be gold transcripts. I'm going to talk about some ways that you can clean the data and the effects that this has on the performance of your training. If you take things from first principles, anytime you want to train with a training dataset, you should ask yourself what the quality of that training dataset is. That means probably hand transcribing at least 50 or 100 examples and measuring the word error rate of that training dataset versus your ground truth transcriptions. This will give you a measure of the quality of that dataset. Now, often you might be fine-tuning a pre-existing base model, for example, Whisper or Qwen. And a useful question to ask is whether the error rate of your model, your base model, if you run it over the audio, is better or worse than your dataset. If your starting model is already better than the dataset, it might be hard to improve performance by using that dataset. For example, the word error rate of the dataset, as measured by 50 or 100 manually annotated rows, might be, say, 12%. But perhaps your starting model that you want to fine-tune is at 9% word error rate. That's going to be tough to get an improvement. So you have two options. The first is if you can find ways to filter the raw data set so that you only keep the high quality samples, perhaps bringing your word error rate down to 7%. And now you can see there's a gap whereby the raw data could improve your pre-trained model. The second option is if you can get an open source model potentially and run that over the dataset audio, you can get what's called pseudo labels or draft labels. You can then measure the word error rate of those over your 50 or 100 human labeled examples and see what the quality of the draft labels is. Perhaps the draft model is very strong, maybe scoring 5%, and that might actually be a better source for training than the labeled data that you have from the European Parliament at all. Now, let me go into a bit more detail about the approaches you might take if you want to filter down the data, which is particularly relevant if you don't have a draft model that is strong enough to outperform those raw labels or indeed the pre-trained model that you have. Broadly, I would look at two different methods. The first is using edge error detection with a draft model, and the second is using CTC alignment. In edge error detection, simply you run the draft model over the audio to get another set of labels, and you compare the ends of those transcripts with the raw transcripts. If there are mismatches, you can drop those rows. The second approach for filtering is CTC alignment. This is where you take a CTC model with the text and with the audio. You use it to do an alignment and calculate the confidence of each of the characters that appears in that transcript. If you find some low confidence characters and you can tune the threshold, you can consider then dropping that row because the characters don't align well with the audio that is there. Combining these techniques, you can take your input raw data set, put it through draft edge detection, drop bad rows, put it through a CTC model, again drop bad rows, and then hopefully finish off with a data set that has a lower word error rate than at least the pre-trained model you want to start off with. This is what I do and what we do a lot internally at Trelis. For example, we have this data set here, which is called Vox Populi Platinum, and it's a multiple step filtration of the Vox Populi dataset designed to bring it down in word error rate. Now I can show you some of the results of training on this, starting off by training Whisper Large, which at this point is an older model. If you run the base model without any fine tuning, you score about 8% on withheld test set of Vox Populi, 4 on FLIR, 8 on Common Voice, and 10 or 11 on Common Voice Spontaneous. Now notice if you train on the raw Vox Populi transcripts, you improve a lot on Vox Populi, but you actually degrade the model a lot on the other metrics. And that's because the bad rows are degrading the quality of the model. However, if you do the right type of filtering, then you are able to get an even further improvement on Vox Populi while degrading the performance on other metrics by a lot less. Now you'll still see some degradation, and some of this might be inevitable if the domain is different. For example, scripted and spontaneous transcription are just different, and it's going to be hard to do well on both at the same time. However, you can see that by filtering, you're able to get significantly better maintained performance on out-of-domain benchmarks. Now, things change as you move to a stronger model, for example, Qwen 3 ASR. In this case here, the base performance is already quite strong. If you train on the raw Vox Populi transcripts, you just degrade the performance across the board. Meanwhile, if you train on a filtered dataset, you're able to improve performance significantly on the Vox Populi withheld test set, and you have relatively small degradation across the other benchmarks here. So this is how you can use techniques like a CTC alignment step or a draft filtering for edge detection step to remove the bad rows from your dataset. Now, while this dataset here is for commercial use, if you're not in a position to spend money on curation or buying datasets like this, I do have one simple tip, which is often you can get very good performance by taking an off-the-shelf, ideally the strongest open source model, perhaps Parakeet right now, or maybe Qwen, and running that over the dataset to get draft labels. In many cases, that will perform perhaps almost as well as filtered data. Again, you really have to start off by assessing the quality of the data with some human annotated examples, so you really have ground truth on whether the data is good and how good it is relative to the model you're going to do continued pre-training on, and relative also to other options like draft labels or like a filtered dataset. That's it. For now, let me know any questions as usual down below in the comments. Cheers.